This is Lecture 24 in the FOA series on fiber optics. This time we'll talk about one of the questions we get asked a lot. When do you use fiber, copper, or wireless? And let's start by looking at a little bit of history. Let's go back to 1880. And on the right we see Samuel F.B. Morse and the telegraph, which has already been in use at this point for about 40 years. And Alexander Graham Bell is just starting to commercialize the telephone. And both of these worked on copper wire. Now let's jump a century into the future. In 1980, long-distance communications was either done by coaxial cable, typically buried underground or run aerially, or line-of-sight microwave with those strange dish antennas you'd see on towers, like in the upper right. For 15 years, we'd had communications satellites available with their annoying quarter-second delay. But a new invention, fiber optics, was just starting to become available. And the big selling point of fiber optics is one small fiber could replace a giant cable of twisted pair copper cables. There have been many new developments in communications since 1980. Besides fiber optics, we have the development of PCs and PC networks, Ethernet, and structured cabling. The Internet became commercially available along with IP communications. We added in wireless with cellular phones, Wi-Fi, Bluetooth, and WiMAX. In the mid-90s, we saw hybrid fiber coax cable TV systems offering high-speed internet access, the first real broadband. We saw the advent of voice over IP, where the phone went from POTS, plain old telephone service, to pure digital over basically IP networks. We saw the development of fiber to the home since 2007. And recently it's been smartphones and tablet computers, and even IPTV, video over the internet. The explosion in new communications technologies since 1980 has led to a tremendous increase in typical communication speeds. So from 1.5 megabits per second around 1980, we're now up to 100 gigabits per second, not being unusual in both local area networks, long-distance telecommunications, and the internet. Just look at what's happened to the typical internet connection speed since 1990, when we used dial-up modems at 3200 to 5600 baud. Then we went to cable modems at a megabit per second, fiber to the home at 10 megabits per second, and now being extended all the way to a gigabit per second. What kind of infrastructure can support these kind of speeds? Well, you probably know the answer to that question. The complete communications backbone for the world is on optical fiber now, either on terrestrial or undersea cables. Central offices in metropolitan areas are connected on fiber into the network, and now we're seeing fiber get closer and closer to the actual subscriber, either with fiber to the curb, as shown on the left, or fiber straight to the home on the right. The question is, how will that develop in the future? And the answer is, it will probably be fiber to the home. The problem is that fiber to the curb depends on the old copper pairs that are already in place. And the copper pairs using DSL, digital subscriber line, are simply limited by the laws of physics. The length of the cable determines the bandwidth. Yes, you can use ADSL in bonded pairs, and they help a bit, But the fact is we're running out of usable pairs of copper. So DSL has peaked. Sales are starting to drop, and fiber is moving deeper and deeper into the network. Premises cabling became standardized on UTP as local area networks moved to twisted pair copper from coax. And the architecture of premises cabling looked just like the 1982 telephone cabling that AT&T surveyed, and that became the basis of structured cabling standards. But since the beginning of local area networks, the speed of connections, Ethernet speeds, have gone up by an order of magnitude typically less than every 10 years. So we've gone from 10 megabits per second in the 1980s up to 100 gigabits per second today. Up till now, unshielded twisted pair copper cabling has been able to keep up with Ethernet speeds, at least at 10 gigabits per second. But beyond that, copper cabling appears to have reached its limit, and we're now working with multi-mode optical fiber, which is sort of reaching its limit too. And now we're looking at single-mode fiber for the next generation of local area networks and data centers. Over the history of local area networks and copper cabling, we've literally been through 10 generations of copper, from the original Ethernet thicknet down to category 6A today. In the same time frame, we've gone through only 3 generations of optical fiber, but we're about to start a 4th, as very high-speed networks are tending now to go to single-mode fiber. The one thing which fiber has had to its disadvantages during the same time frame, we've seen 100 different fiber optic connectors. Fortunately, only a few have become popular. What about wireless? It's become the connection of choice for phones, laptops, and tablets because people want to be mobile. They don't want to be tethered to a cable. They want their connection wherever they are. And for countries that never developed a large copper infrastructure to the home, it's the only choice for those places to provide internet access and phone connectivity. Technology has also given us faster and faster wireless connections. Wi-Fi is still about 10 times faster than cellular, but of course it has a much more limited range. But you have to remember that wireless is not wireless. Wireless basically replaces a cable connection to the mobile equipment. It needs a cabling connection to the network to work. Even today's cellular networks are getting away from wireless backhaul because there's not enough bandwidth to accommodate the growth in bandwidth in the backbone to connections of fiber to the tower and even up the tower to the antennas. Wireless and fiber optics have also become fixtures in local area networks. They're a standard part of premises cabling. Wiring is always figured in to connect up access points to allow wireless connections in all of the areas of an enterprise, and fiber is typically used for high-speed backbones. It's even used for direct connectivity for very, very high-speed users like CAD/CAM. So when do you use fiber, copper, or wireless? Well, you use copper in a lot of instances because it's adequate for many applications. Millions of homes are already connected with copper, and as long as you can get fiber close, you can provide broadband connectivity with ADSL or DSL. And the other thing to remember is copper will never go away because almost every PC has a copper Ethernet port that comes free. Users demand wireless for mobility. They like the convenience of having their access anywhere they go. And most modern devices include Wi-Fi, in fact, as well as cellular connections. So you can use the connection that works best wherever you are. All of this, of course, is connected on the backbone on fiber. And this slide about fiber has been around almost as long as that picture from AT&T in the late 1970s. You use fiber optics because of the economics. It transmits more data faster over longer distances than any other medium. It basically costs less than 1% as much to connect up over fiber as it does over any other means of communications. Fiber provides advantages in weight and size, making it easy to cable. It offers freedom from interference with electrical isolation and security. It's very hard to tap. And every network is available with an interface for fiber, either directly or with a media converter. At the Fiber Optic Association, we believe all these media, fiber, copper, and wireless, are absolutely necessary and must work together to provide the network infrastructure we need in today's world. We're the Fiber Optic Association, the professional society of fiber optics. If you want to know more, go to our website, www.thefoa.org.